All right, section 2.4 is dealing with mathematical models. So up until this point, we've just been looking at equations with no real context to them. Now what we're going to do is see that these equations actually represent things we would want to measure in the real world. So it's sort of kind of getting into what most students would think of as traditional like word problem territory. So a model is an equation that best fits a set of observed data points. The model cannot predict values outside of the domain of the original set. And if the data set is not available and the model is given out as an equation, pay attention to the context for the model. So for example, do negative values make sense? Can you have very small numbers or very big numbers? So for example, let's look at number 9. The equation g of x, right, is 8.98x plus 11.54, models the expected grade on an exam based on the number of hours a student studied. So it says answer the following. What is the expected grade for a student who studied 5 hours? And so here's what we want to figure out. So x in this problem is the number of hours. And g of x, the values that come out, is the grade. So we want to know what is the expected grade for a student who studied 5 hours. So we want to know what g of 5 is. So in order to get this, I'm going to go back to my calculator, and in my y equals, I'm going to type this model into y1. So 8.98x plus 11.54. So then we're going to graph. And now I can use the second calc feature value and plug in 5. So we would expect a student who only studied 5 hours for this particular test to get a 56.44 as their grade. So it says if the application domain is this, so hopefully clearly you guys are okay with that. Dot is supposed to be a parentheses, right? You can't just have one number in a domain. So the domain is saying 0 hours to 10 hours. We want to know, well, what is the range? So since this equation is just a line, and if we actually look at it on our calculator, we can just see it's a line with positive slope, right? So 0 hours would be the lowest grade you would expect, right? And then 10, the graph continues up here. So notice I can't really see a lot of what's going on up here. The graph's sort of invisible right past here. So one thing you can do on your calculator is if you go to Zoom Fit, Zoom Fit leaves the X values alone, but adjusts the Y values so you can actually see the graph. So see, now I can see how it's behaving in the variable. So it just adjusts the Y scale for you, but it left the X scale the way we had set it before. So now I can see here it's 0, right? And then at 10 hours, it's climbing. So I just need to know what this value is and this value is to get my range. So g of 0 and g of 10. So I'm going to go back here. We're going to go to second calculate, value. I'm going to plug in 0, and I get an 11.54. And I'm going to plug in 10, and I get 101.34. So the lowest grade with no studying we would expect is 11.54. And if a student studied 10 hours, they would expect to get a grade of 101.34. So the range must be written in interval notation. And since 0 and 1 were included in the domain, then I have to make sure I include these values in the range. So notice this was bracket, bracket, so I need a bracket and a bracket. How many hours should a student study to expect a grade of 95? So now we've been given a Y value, right? And we want to make sure, we want to know what X value corresponds to that. So we're going to go back to our Y equals, and we're going to plug in 95 for a second function. Now when I graph, I should see 95 moving across there. So I just want to find the intersection of these two graphs. So second, calculate, intersect. So notice I'm scrolling down. I'm kind of doing that so you guys can see what's up. But if I just hit the number 5, it automatically takes you into that function. So it's grabbing the line. It's grabbing the other line. Now when it says guess, we hit enter. And so it's saying the intersection is at 9.29. That gives you a 95. So a student should study about 9.29 or 9.3 hours. So for the purposes of this review, I'm just taking all of these numbers to about 2 decimal places. But notice on your exams, they will be very specific. So some problems they might say 2, sometimes they might say round to 3, but just make sure you follow the instructions on the questions given on your exam when you're rounding. So this completes chapter 2, and we'll see you for chapter 3.